So we have discussed about integration of the polynomial function, several integration techniques. Basically, if we have x to the power n dx, whenever x is a non-negative number, so we prove that n plus 1 over n plus 1, where n is not equal to minus 1. Okay, so here we discuss some other techniques to obtain the uh, integration of a given function. And if you have some kind of integration 2x square root 1 plus x square dx, so the usual integration formula that we have discussed in the previous lecture, they are not working to evaluate such integral. So therefore we need some other techniques how to obtain the integration of this kind of problem. So the idea is you substitute part of this integral function by some other variable. For example, in this case, you can choose, since we have the square root, to remove the square root, I take 1 plus x squared as u. So then later on, you will see that how it changed the integral when we substitute u is equal to 1 plus x squared. Now, in this case, if u is equal to 1 plus x squared, you differentiate both sides with respect to u. So then you get du over dx is equal to integration of 1 is 0. Differentiation of x squared is 2x. Now you can multiply by dx. So then from here you get du is equal to 2x dx. 2x dx. One can say the differentiation of u is du, differentiation of x squared is 2x, and the differentiation of x is again dx. So therefore, then you substitute u is equal to 1 plus x squared 2x dx, then you can say dx is equal to du over 2x from here. So in this case, if this is the integration, so this integration can be written integration 2x. For the moment, we substitute 2x as it is. 1 plus x squared is u, square root u, and dx is du over dx, 2 dx. Then 2x is should be 2x, not 2 dx, du over 2x. Now 2x is cancelled. Then you have integration square root u du, and square root is u half. Integration is done with respect to u, that is u 3 over 2 over 3 over 2 plus c, because half plus 1 is 3 over 2. Then maybe you can write better way, half plus 1, half plus 1 is 3 over 2 divided by 3 over 3. Then you have 2 over 3 u to the power 3 over 2 plus c. But in this case, the answer is in terms of u, but u is not in our original problem. So we have to substitute once again u as 2 over 3. U is 1 plus x squared, 3 over 2 plus c. Now you can see through the substitution u is equal to 1 plus x squared. So we can easily integrate the given problem. So even though at the very beginning we cannot use any usual integration techniques, integration formula to obtain to integrate this I. But when you substitute u is equal to 1 plus x squared, then after some work, you can convert your integration so that it is an integrable function. Okay, and remember, once you obtain the integral in terms of u, you have to replace u by your substitution u is equal to 1 plus x square. Okay, so here the details and the similar one. One more question. So this rule is known as substitution rule. In general, if u is a function of gx, and if we have integration of the form fu du over dx, then this is equal to f u is gx, then du over dx is g dash x dx. So this is equal to, from here dx is cancelled. It's not exactly cancelled, but you can assume such that here you have fu du. That's how you have to substitute some function gx by u g dash x dx. Okay, so what we have said in the theorem, substitution rule, if u is equal to gx is a differentiable function and the range is an interval, but don't worry about this range. F is a continuous function on the interval, then f of gx times g dash x dx is equal to fu du. Even though this is a formula, but we are not going to use this as a formula. So we always work from scratch. For example, suppose we have the integration x3 cos x4 plus 2 dx. So in this case, you take this cos inside of function we have x4 plus 2. So therefore we replace u is equal to x4 plus 2, then du, you differentiate both sides with respect to x. So differentiation of u is du, differentiation of x4 is 4x3, and differentiation of x is dx. So du is equal to 4x3 dx. From there you get dx is equal to du over 4x3. Then you have the integration I x3 cos x4 plus 2 dx. We substitute x3 remain as it is. Cos x4 plus 2 is u. Dx is du over 4x3. So x3 is cancelled. So when you choose the correct substitution, always this x term, remaining x term will be cancelled. So 1 over 4 cos u du. Now you can apply the integration formula for cos, that is sine plus c. Now you have to keep the answer in terms of x. So therefore 1 over 4 sine u is equal to x4 plus 2 plus integral constant. That is the answer. Okay. So once again, with more details here. Cos u half of u, half of cos u, sine u, and replace u by x4 plus 2. So this rule is known as substitution rule for integration. One more example. So u is equal to 2x plus 1, for example. Probably in this case you can get different one. Okay, so you can take 2x plus 1, then du differentiation of u to x, differentiation of x is dx plus differentiation 0. So dx is equal to du over 2. Then integration 2x plus 1 square root dx. Replace 2x plus 1 by u square root u. Dx is du over 2. Then you have half of u is u half du. Now half of integration of u half is half plus 1. Half plus 1 is 3 over 2 plus integral constant. Then half of 2 over 3, not integral sign, u to the power 3 over 2 plus c. Now you have to replace 2 is cancelled, 1 over 3. U is 2x plus 1 to the power 3 over 2 plus integral constant. Okay. So once you correctly identify the substitution function, the rest is very easy. So the details, you get the exactly the same answer. Okay. One more question. So in this case, x over square root 1 minus 4x squared. So I will work here. So you substitute u is equal to 1 minus 4x squared, because inside we have square root 1 minus 4x squared. So in this case, du is equal to minus 4. Differentiation of x squared is 2x. Differentiation of x is dx. Then you get dx is equal to minus du over 8x. Then you have the integration x over 1 minus 4x squared dx. Then x remain square root 1 minus 4x squared, that is square root u. Dx is minus du over 8x. So x is cancelled. So we have minus 1 over 8. U half means u minus half du. Then minus 1 over 8. U minus half plus 1. Minus half plus 1 is half plus c. So then minus 1 over 8 u half. 1 over half becomes 2 plus c. So minus 1 over 4. Replace u as 1 minus 4x squared. Half means square root plus c. So it's like the same answer. So the main thing is you have to correctly identify the substitution function. U is equal to 1 minus 4xr. So here e minus x du. So u is minus x. So if you have u is minus x, du is equal to minus dx. So dx is equal to minus du. Then the integration I is equal to e minus x dx. E minus x means u, dx means minus du. Then it have minus eu du. Integration of eu is eu itself. plus c integral constant minus u is minus x plus c integration. Okay, now one more. The second one, we have x3 2 plus x4 to the power 5 dx. So we are given the substitution 2 plus x4. So u is equal to 2 plus x4. So du is equal to, this is 0 plus differentiation of x4 is 4x3. Differentiation of x is dx. Then from here you get dx is equal to du over 4x3. Then the integration x3 2 plus x4 to the power 5 dx 0 x3 2 plus x4 is u, dx is du over 4x3. x3 is cancelled, 1 over 4 u to the power 5 du. So 1 over 4 u5 is 5 plus 1 is 6 over 6 plus integral constant 1 over 24. U is 2 plus x4 to the power 6 plus integral constant. Okay, that's how you get the formula. Third one I will leave as a homework for you. Question number 4, we have dt 1 minus 60 to the power 4. Your substitution is given 1 minus 60, then du, this is 0, minus 6 times differentiation of t is dt. So then dt is equal to minus 1 over 6 du. Then integration dt over 1 minus 60 to the power 4. Dt I will write separately, 1 over 1 minus 60 is u to the power 4. Dt is minus 1 over 6 du. So then I is equal to minus 1 over 6, 1 over u4 du. So you can rearrange it as u to the power minus 4 du. Then minus 1 over 6, u minus 4 plus 1, that is minus 3 plus c. Then you have minus minus plus 1 over 6 into 3 is 18, u to the power minus 3 plus c 1 over 8, 1 over u3 plus c. You can replace u. Here you have 1 over 18 over u is 1 minus 60 to the power 3 plus integral constant. Okay, that's how you obtain the integral. Question number 5. So we have the integration cos 3 theta sin theta d theta. We are given the substitution u is equal to cos theta. Then du Differentiation of cosine is minus sine theta. Differentiation of theta is d theta. So you can replace d theta as minus du over sine theta. Then the integration becomes cos 3 theta sine theta d theta. Now replace cos theta is u to the power 3. Sine theta remain as it is. D theta is minus du over sine theta. So sine theta is cancelled with minus u to the power 3 du minus u to the power 3 plus 4 is 1 is 4 plus integral constant. Replace u as cos theta. So that's the answer for question number 5. Now, question number 6. Sec squared 1 over x over 1 over x dx. Substitution is given by u is 1 over x, that is x minus. So du, differentiation of x minus, so minus 1 x minus 1 is minus 2. Differentiation of x is dx. So the rule x to the power n differentiation is equal to differentiation of xn is xn n minus 1. Differentiation of x is dx. That's what we have done. So this is minus 1 over x squared dx. Then integration becomes, okay, from here you can get dx is equal to minus du times x squared. Okay, now we replace integration. Sec squared 1 over x should be not x but x squared. I have wrongly copied it. Over x squared dx. So substitution with u. Sec squared 1 over x is u. Dx is minus x squared du over x squared. So you have minus sec squared du. Differentiation of tan is sec squared. So therefore integration of sec squared is tan u plus integral constant. So it is equal to minus tan u is 1 over x plus c. That's how you obtain the solution of the integral. In some cases, you may do not find the substitution. You have to see what should be the substitution. For example, for question number 7, if you have x sine x squared inside dx, in this case, you know that it is hard to deal with the inside of x squared. So therefore we substitute u as x squared. So therefore du is equal to 2x dx. So dx is du over 2x. Then the integration x sine x squared dx. Then x sine x squared is u, dx is du over 2x. Now when you choose correct substitution, always the integral convert as an integral function. So you can apply the formula. Different integration of sine is minus cos u plus integral constant minus half cos u is x squared plus c. The important thing is correct substitution. After integrating, you have to substitute u is as 1. Okay. So here I will write down the u substitute x3 plus 5. And here corresponding substitute is 3x minus 2. Here 3t plus 2. So I will do this one. Question number 11. We have x plus 1, 2x plus x squared dx. Now it is hard to deal with inside of square root. So therefore I replace u as 2x plus x squared. Now it is bit different. Du is equal to 2 times differentiation of x is dx plus differentiation of x squared is 2x, differentiation of x is dx. Now you can see 2 dx is common, 1 plus x, 2 dx. Then you get dx is equal to du over 2 times 1 plus x. Then the integration x plus 1 square root 2x plus x squared is u, dx is du over 2 times 1 plus x. So x plus 1 is cancelled. So you have half of u half du. Then half of u to the power half plus 1, 3 over 2 plus integral constant half of 3 over 2 becomes 2 over 3, u to the power 3 over 2 plus c. So 2 is cancelled, 1 over 3. U is our substitution 2x plus x squared 3 over 2 plus integral constant. So that's what the solution. Okay. Here you can substitute u is equal to x squared plus 1. U is equal to 5 minus 3x. U is equal to ex because inside of sine is hard to deal. And inside of sine you can say u is equal to 5t. And here the denominator is x squared plus 1. So therefore you can substitute u is equal to x squared plus 1. So like this, using this substitution, you can easily get the integration. So that rule, substitution rule, is a very important rule in integration, especially in the next semester. You will, if you are taking the differential equation course unit. So this substitution rule will be very important. You should know how you have to correct. You have to choose the correct substitution and correct integration technique. Okay, thank you very much. So I stop this lecture from here. Thank you very much.